Namaskar. I'm Rudra Kafle from Worcester, Massachusetts. So today I'm going to do a new experiment, a kind of application of Newton's laws of motion. So what we are doing since last several weeks we are learning about Newton's laws of motion and applications. In the previous class, we learned about simple pendulum. Okay. Let me adjust the volume. Okay. So in the last class, we learned about simple pendulum, and using simple pendulum, we also measured the acceleration due to gravity. I measured the value of z at Worcester, Massachusetts, and probably you also measured the acceleration due to gravity in your place. Okay. So today I will be doing some qualitative experiments, and then now I am turning towards more and more quantitative, like to measure some values of physical quantities, right? So these quantities which I am measuring here I am using very simple locally available materials, right? So they may not be very precise. Okay, so please try to understand me that I am using locally available materials. They may not be very precise, but they will tell you, they will give you a very good concept. So how to do physics experiments in a simple way, in a fun way. Okay, so today we'll be talking about friction. Right, I already introduced friction in my previous episodes. You can watch in YouTube. Okay, if you missed those sessions, you can watch them. Right. So what is friction? Friction is force between two surfaces in contact. That is friction. So friction is force. Okay, friction is force between two surfaces in contact. Okay, if the two surfaces, right, tend to move, one surface moves relative to the other, right? One surface tends to move relative to other, or actually moves relative to the other. So there is friction, right? So I mentioned in the previous episodes that friction appears as a result of electromagnetic force. There are four forces in nature, right? Gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. These are four fundamental forces in nature. Out of that, what we are talking about in friction is electromagnetic force. When two surfaces are in contact with each other, right? So they are the atoms and molecules are in very close contact to each other, right? So because of that, and you know that the matter is made up of charged particles, right? I mean the atoms are electrically neutral, but it has protons and neutrons. Protons are positively charged particles in the nucleus, and electrons are around the nucleus, right? So because of these charged particles interaction, right, so there is electromagnetic force, and as a result of that we see friction. Okay, we get friction. Now let me do some qualitative experiments, and then I will do a couple of quantitative experiments to measure coefficient of friction. Okay, let me repeat. This is coefficient of friction. coefficient, coefficient of friction. So what does it do? The coefficient of friction is a quantity which characterizes the surfaces, right? So for example, which surface is rough, which surface is smooth, right? So it characterizes the smoothness of the surface. Okay, so let me show you some quick thing which I showed you in the previous classes also, right? So I have this object. Okay, so I used in one or two episodes in the previous episodes. So this is a coaster. Okay, one surface is smooth and other surface is rough. Okay, one surface is smooth and other surface is rough, and one surface has it is some kind of plain paper, right? You can see here, and the other surface is cork, which is rough. and it is made intentionally that way, okay, so that it does not slide easily, okay, and then prevents like whatever we put on top of this from sliding, okay. So so you may raise a question, you might have a question like, so why do we worry about friction, right? Why friction? Why do we need to study friction? As I mentioned in the previous episode, that friction is a very essential force, right? It also causes loss of energy. So sometimes friction is called necessary evil, right? NECSSARY, necessary EVIL. What does that mean? We need friction, right? But friction also causes the loss of energy. It causes wears and tears in machines, right? So, but without friction, we cannot walk. Without friction, let me give you one simple example. Without friction, an electrician cannot go up in his or her ladder, right? So, electrician's ladder. If you consider a ladder, right? Right? This is not a ladder, it is a bar, but if you imagine that this is a ladder, right? So one end is resting against the wall and other end is against the floor. By the way, this ladder problem is a very classic problem in college level physics, okay? So if you consider a ladder like this, right? So one end is supported on the floor, other end is resting on the wall. So if there is no friction, then what will happen? The ladder will slide, right? The electrician cannot climb. Cannot climb to the ladder to fix the, let's say, wires on the poles and like that, right? So this is one of the very important application in our day-to-day life. What else, right? Friction can be applied, right? Without friction, we cannot walk, right? On the other hand, friction is also not useful in the sense that it causes the waste of energy, for example, or it causes wears and tears of moving parts, okay? So, for example, like consider a very simple thing. If you rub yourself against the wall for a long time, using like wearing your new shirts on, what happens, right? The shirt will finally tear, right? So the same way, there will be wears and tears in the missing parts which are moving because of friction, okay? And let me also remind you, there is a special branch of physics called tribology, 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 which does research and studies about friction, okay? This is a good, big research area. The reason is friction always causes loss of energy, so we would like to minimize friction where we want, okay? Where we want less friction, okay? So let me do some simple qualitative experiment first, and then we measure the coefficient of friction. By the way, when I'm calling two things here, friction and coefficient of friction. Friction and coefficient of friction. They are two different quantities, okay? People are often confused about the two being the same. That's incorrect. Friction is force. Coefficient of friction is a dimensionless quantity, okay, which characterizes the surfaces, how much friction, how much roughness is there, okay? So friction is force, which is measured in Newton. Coefficient of friction is a quantity which has no unit, right? It is the ratio of two forces. I'll tell you in a minute what those two forces are. Of course, one is friction itself, okay? So now let me show you a very simple qualitative example, okay? So here I have this wooden bar, okay? I have this wooden bar here, okay? I have marked a red line here. The distance from this end to this point, I have measured this distance, which is about 50 centimeters, okay? So it is 50 centimeters. When I do quantitative experiments, so that number is needed for calculation. But for now, let me show you. I have this I have this coaster in my hand. So there are two surfaces, of course. One is smooth, looks smooth, and the other is rough. So let me put this coaster on top of the bar, wooden bar, right here, and then put on the side a smooth surface. So what I do is, now I raise it, I lift it, please watch. So it now slid down at certain height. But now let me reverse the side of the coaster, rough side. Let me put here, and then please watch whether the what happens, to what height the coaster starts sliding down. Okay. So you can see. Okay. See, I raised a pretty good amount of height. It has not started sliding down yet. Now, see, I raised a good amount of height, then it started rising, right? Right? So, why is that? Why is that? So, let's talk about the physics here, right? So, this surface was smooth when I put here, right? When the bar is just horizontal, right? How many forces are on the coaster? Please think for a couple of seconds. My question is, I have this coaster, smooth surface on top of a wooden bar. My question to you is, how many forces are there on the coaster, on this object, when I put on top of the wooden bar? That's my question. Okay. Could you please type in there in the comments? Okay. So, probably you did correct. So, there are two forces, right? One is the weight of this object, right? The Earth's gravity pulls it vertically downward, right? So, we are doing this for a long time, for several episodes, so you are already comfortable with that, right? But from Newton's second law of motion, if that is the only force, right, F equal to ma, then the object will accelerate. It should not be living there. It should be moving, right? But see, this object is staying here at rest. It is not moving, right? So that force of gravity, you can also call weight, W-E-I-G-S-T, weight, right? So that must be neutralized by some other force. What is that force? That is the reaction force. That is the reaction force which is vertically up. Okay? So that is the reaction force which is since this plane surface, wooden plank, is horizontal, so the normal reaction is vertically up. So those two forces are exactly equal in amount and opposite in direction, and if you add those two forces, you will get a zero force. Make sense? The net force is zero. So when you do F equal to ma, net force is zero, so acceleration is zero. But now, when I lift it up, still there are two forces. Still there are two forces, not more. What are those two forces? One is the weight, which is vertically downward. But as I mentioned in the last class, the normal reaction is not vertically downward anymore. Okay? This idea is needed in when I start doing some quantitative experiment. So please pay attention to this, right? So when I lift it up, when I lift the bar, still there are two forces on the coaster, right? What are they? Gravity, weight of this object, which is vertically downward. Weight is always vertically downward towards the center of the earth. So no matter what, weight is always vertically downward, right? Make sense? Okay? And there is another force, the normal reaction. So the normal reaction follows the surface. Okay? It is always perpendicular to the surface. Okay? Let me clarify a little bit more on this. When the surface is horizontal, normal reaction is vertical. But when I lift the bar vertically up, see, the surface becomes more and more inclined, right? And normal reaction is perpendicular to the surface, so it is now showing that direction. So when it becomes vertical like this, right, normal reaction is actually horizontal, right? So this part is often confusing. So please be careful. Normal reaction is always perpendicular to the surface, right? Always perpendicular to the surface. Suppose you go against the wall, you press your body against the wall, right? Vertical wall, the wall is vertical, right? The wall is vertical. So if you press against the wall, the friction is perpendicular to the wall, it is horizontal. Wall is vertical, normal reaction force is what? In what direction? Normal reaction force is perpendicular to the wall, right? Exactly the same thing happens in the ladder. So when you put the ladder on vertical wall against the vertical wall, right, weight of this ladder is of course vertically down, gravity is vertically down, right? This is a plank, but I am considering this to be a ladder for time being. And on the floor, normal reaction is vertically up. I have used the top of the table, so that is vertically up. But on the wall, so this end, the upper end is against the wall. So normal reaction is perpendicular to the wall, right? So all these forces, all these kind of forces will balance the ladder on the wall when an electrician climbs up in the ladder, right? Of course, there is one more force on the ladder. What is that? The weight of the electrician, right, which is also vertically down. Okay. Now, so now let me go back and explain this example, right? So smooth surface, I put on the wooden bar and I lifted it up, right? So at some point it started sliding. Why is that? So what happens is normal reaction is that way, perpendicular to that. Gravity, weight is vertically downward, right? Gravity is vertically downward. So what happens is the gravitational force, which is vertically downward, like this, vertically downward, you can split this force into two directions because force is a vector quantity. Okay? Do you remember we talked about vector quantity in the previous class? So this is vertically down, right? And you can split along the surface and perpendicular to the surface. Let me repeat, right? Weight is vertically downward. You can split this force, you can break this force into two components. One is along the surface, other is perpendicular to the surface. One component is along the surface, that way downward, along the inclined plane, right? And other is perpendicular to the surface. So this perpendicular component and the normal reaction, they balance each other. The perpendicular component of the weight, perpendicular to the surface, okay, will balance what? Will balance the normal reaction due to the inclined plane on my coaster, right? But the parallel component is that way, right? Parallel component is that way. But see, if there is only that component, if there is the only component, that parallel component of the weight, no matter what, whatever amount I lift the bar, right, it should slide, but it does not. It does not slide. You can see here, I am doing experiment in front of you, right? I am doing experiment in front of you, right? So it is not sliding, but it starts sliding only at certain height, okay? Only at certain height. Why is that? While up to reaching that height, so there must be another force, right? There must be another force at all times. What is that force? The force this way is the component of the weight, and there must be another force opposing that. That is the frictional force. Okay? So at certain height, what happens? At certain height, when those two quantities become exactly equal, okay? When those two quantities become exactly equal, what two quantities? One is the component of the weight along the plane, other is friction backward. When those two quantities become exactly equal, right? So this object is on the verge of slide. This object now about to start to slide. And if I slightly change the height, if I slightly raise the height, so it starts accelerating. Now what happens? The reason is now friction is not enough to support the component of the weight in that direction. So which wins? The component of the weight wins the friction, right? So that's how sliding starts. On the other hand, if I use the cork part, the rough surface, now exactly the same thing happens. But the reason it does not start slide at the same height as before is there is rougher surface in contact with the wooden plank, right? The surface is rougher. It is rough compared to the previous surface, right? Compared to the front side, right? So what happens? Again the same thing. Again the same thing happens. The component of the weight doesn't change because the weight of the coaster doesn't change. No matter whether I put this way or that way, the weight doesn't change. But what changes is the surface area, the nature of the surface. Not surface area, the nature of the surface. Now I have a rougher surface. So if I start lifting now, okay, please watch, right? Please watch, start lifting now, okay? See, it's a pretty good amount of height. Right now it started sliding, right? So friction is, this example can be used, this experiment can be used, this simple experiment can be used to calculate the coefficient of friction, okay? So let's be more quantitative. Let's do some measurements, okay? I am doing the simplest kind of measurement, okay? Because my goal is everyone who is staying in home, right, because of this COVID-19 problem, right, this pandemic. So everyone who are staying home should be able to do this experiment and then learn a lot of physics. That's my goal. Learn the concept both qualitatively as well as quantitatively, okay? So now, what I am going to do now is I am doing some measurement, okay? I am doing some measurement, okay? So I will use the same coaster, the same thing, right? And then what I do is I put on the smooth surface, I put the smooth surface in contact with this. And let me slightly move myself in other side, okay? Yeah. So, okay, so what I'm doing is now, so I am measuring the height, right? So see, this originally, in the beginning, the wooden plank, the wooden bar is horizontal, right? Horizontal, it is lying on the top of the table, okay? Right, what I now do is, so I am considering that to be zero height, okay? To be zero height. So what do I do now is I now put the ruler, right, which is 30 centimeter long. You can read it, okay? 30 centimeter long. So I am putting here this way, okay? So I am lifting it up. I note the height. I note the height when the coaster starts sliding, okay? So let's do that. Let's do that. Okay, so one second. There is, I believe, I put in. Okay, one second. Okay. Okay, so let me do. Okay, so it started sliding. It started sliding when the height was 22. It started sliding when the height was 22. Okay, so what I do is I now note down two quantities. One is the height. Okay, let me write that. So you can also, if you have a pen and paper, you can also write the height was 22 centimeters. Okay, the height of the edge, okay, which is at a distance of 50 centimeter from the other end, right? This from this end to this point. So height was 22 centimeter, and length of that section was 50 centimeter. Okay, the length of that was 50 centimeter. Okay, let me explain these quantities one more time. So what I did is, when I lifted it up, so from this edge to this mark, right, this mark, that length I already measured, you can measure, right? So that was 50 centimeter, right? And then I lifted this bar to this height, and then I noted the height from the top of the table to this point, right, which was 22 centimeters. So let me do a small calculation. Then what you do is you divide h by L. So divide h over L. Okay, divide h is 22 centimeter, L is 50 centimeter, right? So 22 divide by 50. So this is 0.44. This is 0.44, right? It has no unit because 22 centimeters in the numerator, 50 centimeter in the denominator, centimeter and centimeter I can cancel. So this coefficient of friction, the coefficient of friction between the smooth surface and the top surface of the wooden plank was that. So let me now measure the coefficient of friction. By the way, that is it. That's the very simplest calculation, right? We can measure that quantity other ways also, right? By measuring the angle between the wooden plank and the floor or the top of the table when I lifted it up, and at that time the coaster started sliding, right? So there are other ways also, but I am choosing the simplest of the way so that everyone can do. Okay, so now let me change the experiment. Now I am using the rock surface at the same distance, right? And then I will be measuring the height when the coaster starts sliding. Okay, so let me do that. It might be that there will be height. This ruler might not be enough, but let's try. Okay. Yeah. So the ruler was not enough. It was about, let's say, about 2 centimeter above 30. It was about 2 centimeter above 30, right? So it was about 2 centimeter above 30. What is that? So the new case, 2 centimeter. So that is 32 centimeter, right? I slightly approximated there because my ruler was not long enough, right? So 30 centimeter was this length, but the coaster started sliding slightly above that, about 2 centimeter. I estimated that, and but the length of this marked bar, from one end to the mark, I haven't changed that. So that is 50 centimeter. So let me calculate mu s, coefficient of static friction, is equal to 32 divided by 50, right? So it is 0.64, right? So see, now you may ask a question, so what's the point, right? So we know that this is the rough surface, and we know that this is a smooth surface. So what's the point, right? But this is very important, right? So expressing some measurements, doing some measurements and expressing into numbers, that is actually the doing of physics. Okay, that is doing of physics. Of course, conceptually, what you say, this is a smooth surface, and that is the same surface we are using for both experiments. right? And this is the rough surface. Of course, the rough surface will, the friction between the rough surface and the wooden bar will be more than a smooth surface, right? Right? You can say that, but do science, okay? Do science. So do means do some kind of measurements, do some kind of calculations, okay? That is very important, right, in learning science, learning and doing science. So now what we can say, what we confirmed by measurements, that this surface, right, this surface is about, let's take the ratio of these two quantities, 0.64 divided by 0.44, right? So see, this surface, this cork surface, wooden surface, is about 1.5 times rougher than this surface. This surface was about 1.5 times less, smoother than this surface. Okay? So this is a very crude experiment, but it does pretty good job. Now, I would like to tell you why we, let's do some calculation. So if in the audience are students of lower grade, probably the calculation will be a little bit more for you, too much for you. But for the college students, it is useful, right? You will understand. So what I do is, now I turn to my phone to camera mode to show you some calculation. Okay. Why did we use like h over L? H over L, the length of the plank in the denominator. H is the vertical height. So why did we use that? So let me show you some calculation. There is some right. So there should be some theory behind it. So what is that? So I have converted my camera, my phone into camera mode. Okay. So I have done this calculation. So if you are a college student, probably you are already familiar with that, right? So please see the diagram. Okay, let me quickly explain to you. I have written here on the top coefficient of friction. Okay, coefficient of friction, mu s. By the way, this quantity is called static friction. Okay, coefficient of static friction, because the object was about to slide. But once the object starts sliding, the story changes. Then we call what we measure is the kinetic friction. Okay. Now see, this is the plank, right? You see this inclined plank. So about this height, about this height. So when I raise this plank, wooden plank or the wooden bar to this height, which is h, right? So this object started sliding. Okay, right? So weight is vertically downward. Weight equal to mg. Please don't forget to give the arrow. That arrow is important. Weight is vector, m is mass, is a scalar, right? And g is acceleration due to gravity, which is a vector, right? So then what I do is I split this weight into two components, mg cosine theta and mg sine theta. Mg sine theta is along the inclined plane. Mg cosine theta is perpendicular to the plane. Okay, there is some geometry. By the way, what is theta? The angle theta is the angle between the inclined plane and the top of the table in my case, when at the instant when the coaster started sliding. Okay, right? So what you can say, there is no motion in that direction. So this normal reaction, which is perpendicular to the surface, right, and mg cosine theta, right, they will cancel, right? So now what are the left forces? As I explained before, mg sine theta, that is the component of the weight along the inclined plane, and the friction. Okay. Now there is an empirical formula. There is okay. So now let's continue. Right. Let's continue. We know F equal to ma. That is Newton's second law of motion. Right. F equal to ma. And by the way, I have written a letter sigma here, which shows that sum of all forces, that is the net force. Okay. In one of the previous videos we talked about that, right? So sum of the all forces is equal to ma, that is the Newton's second law of motion, right? In the previous class I used that sum of the all forces For that I use simply F. Okay, I use the force F, right? So F equal to ma, right? So at equilibrium, when the object is about to slide, what we can say, normal reaction is equal to mg cosine theta, and then friction is equal to mg sine theta. Okay, so let me go to one more step. Okay, let me go to one more step here, right, and then tell you more, right? So here there is an empirical formula called force of friction F of F is equal to mu s times Fn, right? So mu s is called the coefficient of friction, Fn is the normal reaction. So now if you plug mg cosine theta down here, right, then what do you get? And then equate mu s n Fn is equal to mg sine theta, and if you simplify, right, so mg and mg you can cancel from both sides, right, and then you will get a very nice relation. Tangent of theta is equal to coefficient of friction. Tangent of theta is equal to coefficient of friction. Okay, now if you have a protractor, angle measuring device, or if you use a smartphone and then track the angle, right, so you don't need to measure the height and the length. But see, go back to this picture, right, from trigonometry. Okay, if you haven't learned trigonometry, please don't worry too much at this point. So this is called the perpendicular, which is opposite to this angle theta in this right angle triangle. This is a right angle triangle, so this is theta, so this is height, right, this is the base, perpendicular and base. Okay, in the United States we usually call opposite over adjacent, right, that's how it is taught, but perpendicular over base, right, so h over L, right. So then in the last expression, tangent of theta, for tangent of theta I wrote h over L, and mu s is mu s, so that is the coefficient of friction. And see, this has no unit because height is in centimeters or meters, length is in centimeters or meters, so they cancel, right. So the coefficient of friction, right, let me convert that into selfie mode. Okay, so what I am saying is we measured the coefficient of friction. Okay, we did not measure the friction itself, but once you measure the coefficient of friction, and if you know the mass of the object, the rest of the thing is easy, right? So what is force of friction? Right, force of friction is equal to mg sine theta, right? And sine theta is not a problem because you know tangent of theta is equal to h over L. So from that you can find theta, right? And then you can calculate the friction. So friction and coefficient of friction are different things, right? They are, one quantity is force, friction is force. The other quantity is ratio of what? Ratio of the force of friction divided by normal reaction, right? That the ratio of two forces. Okay. Now, one final thing before I complete this class is, right, so one very interesting from that derivation, you see that coefficient of friction, not friction, coefficient of friction just depends upon a number, right? I mean, it is a number. It doesn't depend upon how heavy object is or how light object is. But remember, friction depends. Okay, when the object becomes heavier and heavier, friction becomes more and more. What I am explaining here is coefficient of friction doesn't depend upon the weight. So let me do a qualitative example. Okay, I'm doing a qualitative example here. Okay, so I will not be exactly measuring this because I am using about 2.5 kilogram heavy rock. So I don't want this rock hitting my smartphone, right? So what I do is I have a steel plate. I put a steel plate here. Okay, you can do this experiment, okay, in your place. So I have a steel plate. So what I do is I I put this steel plate on top of the wooden bar, right? And then I lifted my wooden bar, right? See, I lifted. So it started sliding here, right? See, it started sliding right here, right? Now, I would like to ask you a question. Please do a prediction, okay? I would like to ask you a question. So please make a prediction. So I don't change the surface, right? In the next time, I still put this surface in contact with the wooden bar. But what do I do is, I put this heavy rock about 5.2 pounds. I measured that, which is about 2.4 kilogram, right? So now I have a question to you. Now I am lifting the wooden bar. I am lifting the wooden bar vertically, right? So I'm asking you a question. So what do you think? Do I need to lift higher or lower than the previous height without the rock, without the stone, right? Only with the steel plate. So do I need to lift higher or lower so that this system of the rock and the steel plate start sliding? Okay, please think about a couple of seconds. And please type in your answer. Please don't worry, whatever you think, please type, be honest, right? Even if you make a mistake, I don't mind, right? That's how we learn, okay? Okay? So hopefully you thought about that, okay? My question is, so previously I did the experiment only with the steel plate on the same, that means there are two same surfaces, the steel plate and the wooden bar surface, right? And then I checked, right, when it started sliding, I stopped here. So the height was something like this, maybe around, let's say, around, what is that? Okay, so sorry. Okay, so it was about 10 or 12 centimeter, 10, 12 centimeters, something like that, right? So now what I do is, now I am increasing the weight, right? I am increasing the weight, but I haven't changed the contact surfaces. I have increased the weight, but I haven't changed the contact surfaces. Now please watch, okay? So I will stop, once it starts sliding, I will stop it right away, because this will roll down and then might hit my my phone, okay? So let me do that. Okay, please watch. You see, the plate has started sliding about the same height, So what does this mean? This means that the friction between the two surfaces, the coefficient of friction between the two surfaces the coefficient of friction between the two surfaces remains the same. It doesn't depend upon the weight. But remember, friction changes, because friction depends on the weight. Okay, let me repeat that in camera mode. Okay, so what I am saying is, see the friction, do you see the friction here? So that friction depends upon the weight, but the ratio of friction to normal reaction, the ratio of friction to normal reaction, which is the coefficient of friction, is independent of the weight. So that's why we could calculate that, right? See, so in the bottom here, mu s is equal to h over L. Okay, so this is very interesting. Okay, so with that, I would really like to thank you very much. So one thing before I stop my video, right? I stop this class. I would like to tell you that. So there were some friends in my Facebook account who really bothered me, sending some kind of unwanted materials in my inbox, and so I don't want those kind of things. So because of that, I limited my access of my account only to my friends in Facebook. Okay, so please, my goal is, I am trying to help the students, the children who are staying home in Nepal because of this pandemic, right? Nothing else. So please, do not send that kind of unwanted materials in my inbox. And if you would like to share with your friends, I will definitely make this video available in YouTube. Okay, so, and also I would also like to thank for your feedback. So many of you sent me email in my inbox or publicly commented that you found, or your children found this series useful. Okay, so please send me more comments. With that, I would like to thank you so much for attending this session, and I would like to end the session. Thank you so much. Have a good night in Nepal, and good day in elsewhere in the world. Thank you.